Today's video is about the GS mini function or the ground speed minimum function. If you have ever been confused as to what it's all about, by the end of this video, it will be clear as to what the GS mini function does and why it is in place. So we know that the GS mini function changes the IAS managed speed target in order to maintain a minimum aircraft energy. That is the textbook definition. We all know that. But before we get into what exactly it is in practical operational terms, let's look at an approach without the GS mini function. So here the aircraft is flying in the approach phase on the localizer runway 07 into Chennai with a selected speed, V approach of 140 knots selected. You can see by the blue triangle there, with a 10 knot headwind. Now let's see what happens if the winds suddenly increase to a 40 knot headwind component. So just keep an eye on the indicated airspeed and the speed target of 140 knots. So the headwinds suddenly increase towards 40 knots, and the indicated airspeed of course will increase because the indicated airspeed is a dynamic pressure indicator from your pitot tube. But the speed target of course remains at the selected 140 knots. And right now what would happen in this frame where the actual indicated airspeed shoots up because of the increase in headwind and the increase in dynamic pressure, but the speed target is still down at 140 knots. The auto thrust will spool the engines back to come back to the selected speed target of 140 knots. And at this moment of time, you are caught with your pants down, because if you're in the final approach segment, especially at a lower altitude, and you have to perform a go around or a wind shear escape maneuver, you may have some speed in hand, but you have very less energy in hand because the engines have momentarily spooled way back to catch your V approach selected speed target. And of course, the jet engine takes a lot of time to spool up, especially from close to idle thrust. So the indicated airspeed will eventually come back towards the selected V approach speed target, and the thrust will stabilize again. But during these critical seconds, you are caught in a very vulnerable situation, especially like I said, if you're at low altitudes well into the final approach segment and you have to go around or perform a wind shear escape maneuver. So GS mini is basically GS minimum, and it's a function of the FMGC where it varies the managed speed target in approach as the headwinds change in order to maintain a minimum ground speed of the aircraft. And it will soon become evident why it does that. A couple of terms that we will discuss along this discussion are: one, V approach, which is in the MCDU perf approach page. And I won't get into exactly how V approach is computed in the first place. That's a different topic, but it's basically VLS plus 1/3 of the headwind component, and the upper limit to that is 15 and minimum 5. So in our example, V approach is 140 knots. The second term is the GS mini value itself, and this GS mini value is not displayed to us, but how it is computed is it's V approach minus the tower reported headwind component, which is basically the headwind component entered in the MCDU perf approach page. The third term is the IAS speed target itself, which is the magenta, I know that's red, but anyway, which is the magenta triangle on the PFD. Oh, I do have a magenta, so we'll change that. There you go. back to black. So the IAS speed target as a function of GS Mini, how it varies is it's basically GS Mini plus the actual headwind component. How does the aircraft know what the actual headwind component is? It gets it from the ADIRS, the same source which indicates the wind velocity on your ND. So the whole point of the GS Mini function is that it constantly varies the IAS speed target in order to maintain a certain minimum ground speed. So in our example, GS Mini is 140 minus 10, which is 130. So that is the minimum ground speed that the GS Mini function varies the IAS speed target in order to maintain. So now let's look at a few examples. So now say the headwind component increases from 10 to 40 knots. So the IAS speed target would become the ground speed minimum value 130 plus 40, which is 170. So in maintaining an indicated airspeed of 170 knots, we maintain a ground speed of 130 knots. Because the wind being not in our control, the only way we can increase the ground speed is by increasing the indicated airspeed. Now, if the headwind component, for example, increases to 20 knots from 10, so we have 130 plus 20, the new IAS speed target would be 150. Now, the upper limit to this IAS speed target is in config full. It would be VFE minus 5, and in config 0, 1, 2, 3 it would be VFE next, and the lower limit would be V approach itself, which is 140. So for example, if the wind drops to 0, so you have 130 plus 0, which is 130, but it's limited to the minimum value of V approach, which is 140. Similarly, if the winds change to tailwinds, if it suddenly changes to a tailwind of 20 knots, ideally it's 130 minus 20, which is 110. But again, the IAS speed target is limited to a minimum value of V approach, that is 140. So just to summarize, we can see that the whole concept of GS Mini is that it varies the IAS speed target, the managed IAS speed target, as the headwinds change in order to maintain a minimum ground speed, so that that minimum energy is available for the aircraft on the approach, especially when you have drastic changes in wind, to avoid the scenario that we saw in our first example of an aircraft in approach without the GS Mini function. So now let's look at the GS Mini function in action. So here we are back in the cockpit in the same scenario that we've been discussing all along. V approach is 140, tower reported and current headwind component is 10 knots, shooting an approach into runway 07. The only difference now is that the speed is managed, as you can tell from the magenta speed target on the PFD, and also we now know what the GS Mini function does and how it varies the IAS managed speed target in response to a change of headwinds. So what's going to happen now is we're going to see a sudden increase of headwinds of up to 40 knots. So you can see the headwind component increasing there, and the IAS speed target, the managed IAS speed target, also increases as we discussed earlier, as a function of the headwind component. So the headwind component is now 40 knots, as we saw the minimum ground speed, that is the GS mini value, is 130. So 130 plus 40, 170. That's where you can see the managed IAS speed target is now 170 knots. And if you remember, its upper limit would be in config full, as is selected now, would be VFE minus 5. So its upper limit is 172, which it will not go above. So I hope that helped in clearing things up a bit regarding the GS mini function. And even though it was explained a little differently from how it was given in the FCOM, which can get a little confusing with all the brackets and minimum of V approach and this and that. So just a couple of more points that I wanted to cover. One is that the GS mini function is an FMGC function and not an auto thrust function per se. So what I mean by that is the IS speed target, the magenta triangle, will keep varying as a function of GS mini as the headwinds change. And if the auto thrust is on or off, it's just that if the auto thrust is on, then the auto thrust will chase that magenta triangle target. And if the auto thrust is off, then it's up to us using manual thrust to follow that IS magenta triangle speed target. Another point is that on the NEOs, the IAS speed target increment is lesser than that on the CEOs. And the reason for this is that the CEOs have a better deceleration capability, so they can afford to have a slightly higher speed all the way down the approach. And the exact explanation is given in Airbus Safety First magazine, issue 24, July 2017. I'll put an image up on the screen. You can pause and have a look. So yeah, like I said, I hope that cleared things up, and I hope it didn't confuse you any further. Anyway, thanks for watching, and see you in the next one.